All right, in this video here, we're going to be looking at roots and radical expressions. So here's a root here. The square root symbol is called a radical symbol. Actually, we've been calling it a square root symbol, but it's actually formally called a radical symbol. The little number here is going to be called the index. It has a connection with exponents, which we'll get to in a later video. And then the number that's underneath the radical there is called the radicand. Now, there's going to be some times, and actually all of the ones that we've done so far, where we don't actually have a number here. So if there's no number there, it's automatically an index of 2, and we've called that square root. All right, let's just look at a couple examples here. We got square root of 25. So this is asking the question, 2 of what number, and it's got to be the same number, when multiplied makes 25. So that's going to be 5, because 2 5s being multiplied equals 25. Now we can also look at it like this. 5 to the second power is saying the same thing. We have 2 5s being multiplied. Square root negative 25. So this actually is, there's no real number that when multiplied by itself makes a negative 25. We already know positive 5 times positive 5 makes positive 25. Well, what about negative 5? Well, negative times negative is also going to be a positive 25. So there's no real numbers that multiply by itself to make a negative 25. What about negative square root of 25? Well, this is something we can do. It's negative 5, right? So we're doing the 5 times itself to give us the square root of 25, and then we need the opposite of that. So that's going to be a negative there. What about negative square root of negative 25? Well, for the same reason as b, it's not going to be a real number. We still can't do square root of a negative and get a real number for an answer. Let's check this out. We got cube root, so the index is 3, so we're looking for 3 of the number multiplied together to make 27. So cube root of 27. Well, that's going to be a 3 because 3 3s being multiplied equals 27. So 3 of the number being multiplied to make 27. Here we go. Cube root negative 27. Now, in this case here, that's going to be a negative 3. With our square roots, it works differently. So, but check this out. Negative times negative is positive times another negative does make a negative. So we can do 3 negative 3s. So 3 negative 3s being multiplied to make negative 27. Here we go, negative cube root 27. Well, that's also going to be a negative 3. So these two super duper similar. Now in this case here, we're doing negative, and remember the cube root of 27, cube root of 27 makes 3. So this cube root of 27 goes right here. And then negative of cube root of negative 27 is going to be a positive 3. So in this case here, this negative goes there. Cube root of negative 27 we did here on b, so that's a negative 3. So the opposite of a negative, or negative of a negative, is going to be a positive. Now we're going to find the cube root of 0.027. So this 27, that looks familiar. Cube root of 27, we know that one, right? Because cube root of regular 27 is going to be a 3, but here we got some decimals in the place here. So we just got to move that decimal place over one spot, and now we got cube root of 0.027 equals 0.3. So we don't necessarily need a calculator for this one. Now let's look at cube root of 125 over 64. So this cube root, it does have a quotient to a power type property. So it's actually going to go to both the numerator and the denominator. So we can do cube root of 125. 3 of, it's got to be the same number. 3 of what number multiplied together makes 125? Well, that's going to be 5. 5 times 5 times 5 makes 125. And for the denominator, 3 of what number makes 64? 4 times 4 times 4 makes 64. So 3 4s make 64, and 3 5s being multiplied make 125. Here we go, square root of 9 times x squared. So same idea as the last one. We can break this up into two smaller chunks. This is kind of like a product to a power type property. The square root is going to go to the 9, and that's going to make a 3. And then the square root is also going to go to the x squared part there. So square root of x squared just makes plain old x. The square root and the square, they undo each other. Now let's do cube root of 8y to the third power. So similar to this one up here, that cube root goes to both the 8 and the y cubed. So again, it's kind of like the product to a power property. So we're going to do 8 cube root of 8. So 2 times 2 times 2 makes 8. And then the cube root of y to the third power. So the cube root and the cube, they kind of undo each other. So that's just going to make y. All right, so here we go. We're going to do the fifth root of 32, x to the 15th, y to the 10th. We are going to break this up into smaller chunks, make it a little bit easier to work with. So that fifth root, it goes to the 32, it goes to the x to the 15th, and it goes to the y to the 10th. So for the fifth root of 32, in our brains we're thinking 5 of what number being multiplied makes 32? Well, that's going to be 5 2's being multiplied to make 32. So the fifth root of 32 is just 2. Now let's look at the fifth root of x to the 15th. Well, we already know that's going to be an x to the some power. And we know that the 5, exponent of 5, and the fifth root, they undo each other. So if we just have an x to the 5th there instead of a 15th, well, that's going to give us plain old x. Well, we're looking for x to the 15th. Well, how many of these x to the 5ths do we have? Well, we got, that's going to make x to the 10th with the 2 5s, and there's x to the 15th. So we're going to have these going 3 at a time. So this one here is going to give us an x, and this cube root or fifth root of x to the 5th going to give us another x. So we're going to have 3 x's being multiplied here. Now, after we do this a while, we'll probably figure out the pattern, but we're just going to take and we're going to go 15 divided by 5 to give us this 3 here, because we got 3 groups of x to the 5th. So this 15 divided by 5 here. Now we need to do the y variable, so we're going to do fifth root of y to the 10th. So if we use our same pattern as with the x's, we're just going to take and do y to the, and then we're going to, in our brains, divide 10 divided by 5. So this 10 divided by this 5 here, or you can look at it here all broken up. So that's going to make 2. 10 divided by 5 makes 2. So remember, the reason this works is because the fifth root undoes the power or the exponent of 5. So if we only had a y to the 5th, that would make 1y, but we need to make y to the 10th. So we're going to have 2 of these y to the 5ths there, and each one of those is going to make a factor of y for y squared there. So remember, we have an index there, we have the radical symbol, and we have the radicand here. If it's a super complicated one, break it up into smaller chunks, do each of those chunks separate, and you'll be on your way to simplifying radical expressions.